In this tutorial, we're going to walk through the toolpath creation for the Vectophone plate you can see on the screen. We're first going to close out this part and open the original vector file. So File, Close. And now I'm going to open an existing file, which is going to be our Vectophone vectordrawing.crv file. And now we're presented with the part and the vectors shown on the screen. So now we can move ahead and start to look at creating the toolpaths. So I'm going to toggle across to the toolpath view now and come across and initially set up my material. Now the thickness of the material we are going to use is 1/8 of an inch, 0.125, and we are going to have our XY datum not in the center but in the lower left hand corner. Our Z0 will be from the material surface, and we just need to check over our rapid Z and home start positions. In this case I'm OK, and I'll click OK to accept that form. Okay, we're now presented to start selecting some of the vectors and creating the toolpaths. So we're going to start by doing an area clearance or a pocketing between the vectorphone text in the center and the inner of the two boundaries. So we're going to pop open now the pocket toolpath, and I'm going to start by selecting the vectorphone text in the center and then shift and pick the inner border. So we've defined the area that we want to pocket. We can now come up to the cutting depth at the top of our form, and we need to specify our start depth, which is 0, i.e. from the top of the material, and we're going to go down by a cut depth of 3/64 of an inch, which I can type on the keyboard with 3/64 and then equals, and that will give us the decimalization of the fraction. We're going to come down and select the correct tool now, and in this case I'm going to initially pick an 1/8 inch end mill. So we'll select that tool and we'll move down now to the clear pocket commands, where we can change the strategy from offset to raster. I'm specifying raster strategy, climb milling, and I'm just going to go down now and we're going to call this now pocket, and I will calculate that toolpath. So we initially then are shown in the 3D view, and if we toggle this to show the 2D and the 3D, you can see the toolpath shown in the 2D view at the top and the 3D view at the bottom. I'll move straight across now and select the preview all toolpaths or simulate, and we'll show those toolpaths on the screen, and I'm actually going to change the toolpath color to be a dark green color. Okay, so we can see that there. Now what's noticeable about the simulation is the fact that we haven't cleared in some of the central areas, in between the P for instance, and we've definitely got some areas that are missing from the toolpath. So that's a function really of us using a larger tool here, so it would be advisable for us to come in and maybe pick a smaller tool. So with that now, I'm just going to double click on the toolpath, which will pop open the original settings and select the vectors. And we'll come across now and look at the tool that's been picked. The tool is an 1/8 inch end mill. So if I select that now and open up the form, you can see the parameters that are set here. And what I'd like to do is actually use a 1/16 inch end mill. So to do that, I'm actually going to select the tool, the 1/8 inch end mill, and come down to the bottom of my form and set to copy the selected tool. Okay. So the right hand form now is presented with the original settings for the 1/8 inch. We're going to change the diameter from 0.125 to 0.0625, which immediately will change the name at the top. And then I'm going to say, okay, what parameters do I want to copy to set my speeds and feeds? So I'm going to base it on the material hardwood and the end mill 1/8 inch that we already set. I'm going to copy those, okay. But I'm going to need to change them because I'm coming down to a smaller tool. I'm actually going to drop this down to say 25 and a plunge of say 10. Bearing in mind we're going to go into hardwoods. I'm erring on the conservative side here, and apply that now. So you can see that's been added in to the database on the left. And I'm just going to just pick that tool up now and just place it at the top. So we've got them in sort of descending order there. So I'm going to select that tool now and come straight over to the form and just hit calculate. Okay. So I'm going to reset the preview now and then preview that toolpath, and you can see now that it's cleared all the areas and we have a representation of our vectorphone text. Now of course that will take a longer time to machine, but rather than specifying two different tools, I just thought I'd cut it with one single tool, bearing in mind it just takes a little longer. Right, we're now going to move through to look at engraving the serial number onto the plate. So with that, I'm just going to close out the simulation now and look at the profiling. So we're going to come up and select the profile toolpath now. And I'm going to pick my text. Okay, so this is going to be serial number 00001. And our start depth. Now our start depth is not from the top of the actual workpiece because we've already specified a clearance toolpath down to 3/64. So our start depth will actually be 3/64. Okay. And we're going to come down just by 200 thou. Okay. And I'm not going to be using an 1/8 inch end mill. I'm actually going to be using a V-bit tool. So I'm initially going to start with my 90-degree 1/2 inch V-bit there. So I'm going to select that as my start point. We're going to machine on the vectors, okay? And I'm just going to come down now and just call this text. And we'll go straight ahead and apply. So we can see that shown in the 2D view and the 3D view. And we're just going to play that now in the simulation to see what we get. And you can see here that we're getting some amount of bleeding across between the text. So we're using probably a larger V-bit with a too greater angle, or we are using a greater depth, which has caused this to sort of bleed across. So I'm just going to undo that last one there now, close that form down, pop the text back up now, and look to either make a change to the cut depth. So I could lower that from say 200 thou to 100 thou, but actually I'm going to change the tool. So I'm going to select that V-bit tool now. This will pop open the form, and I'm actually going to copy my original 90-degree 1/2 inch V-bit. So I'm going to copy that now, okay, which creates a new tool. I'm going to copy the parameters from the original, okay, and I'm just going to change the angle from 90 down to 60 and apply that and select it. So we've added that into the tool database now. I can now calculate for that text, which will give us the new toolpath, and then I can preview those toolpaths, which gives us the text now. And as you can see, it's just about touching, but doesn't bleed across like the original. So I'm very happy with that set there. Okay, so the next stage is for us to move across and look to drill the 4 holes in the corner of the plate. Okay, so I'm just going to resize my 3D view now and bring that back into view, and I'm going to come back and close out that form and select my 4 drill holes. So I'm going to select my 4 corner holes and come across to my toolpath, and I'm going to select the drilling toolpath. And in this case, the start depth will be the top of the block, and my cut depth will be all the way through. If I didn't know what that was, another way of doing that is with Z equals, and that will give us the full depth of the material. I'm happy to be using the 16th inch end mill as the holes are also 16th inch. I'm not going to be using peck drilling in this case because we're only going through by 0.125 of an inch, and I'm just going to call this holes. So we're just going to quickly change the name and calculate that. Okay, so with that now I can just simply preview that toolpath. So I'm going to preview, and you can see that we now have our 4 holes in the corners. So we're now going to move across and deal with the final toolpath, which is the cutout around the outside. Now, of course, we need to be careful here not to sort of break through all the way around, and to leave some tabs here so we can remove the part and then break the actual plate away from the material. So once again, I'm just going to select the vector now and just close out the simulation toolpath form and come across and select the profile toolpath. Now our cut depth, our start depth is set at 0, which is fine. That's from the top of the material, and our cut depth needs to be the full width, full depth of the material. So I'm just going to type in Z equals now, which will give us our 0.125 inch. The tool we're going to use is not going to be the V-bit, of course. We are going to be using our 1/8 inch end mill, a slightly bigger end mill. And we're going to come down now to machine vectors here, where we can go either outside, inside, or on. In this case, we want to go outside, of course, protecting that edge. But what's important here is the add tabs to toolpath. Okay, so I'm going to select that now, and you can see here that we specified a length of the tab of being 0.125 inches and a thickness of just 50 thou. So I'm now going to add those tabs into it, which will give it a support once it's being machined. So I can say edit those tabs now, and I'm going to add in a constant number, just say 4, and add those in. So it's put those in those locations, but what I'm going to do is just actually manipulate. So I'm going to move these now and just simply hold the left mouse key down and then move them around. So I think I'm going to put sort of 2 on the top here, and then I'm going to just put another one, so I can actually click anywhere I want now to add extra ones. So I'm going to click 1 on the side there and 1 on the left hand edge too. So I'll put in 6 altogether now. Close out that form. Okay, so I specify my cutting depths, my tool that I want to machine outside. I've added some tabs, and now I can just come down and call this cutout, and we can calculate that toolpath. So we can see that presented on the screen, and if I just rotate the view there, we can see the cutouts that are shown. Okay, and when I simulate this now, so preview visible toolpaths, we can see those cutouts and the depth, and now we're presented with the finished part. So you can see the combination of our 4 toolpaths, the pocket, the text, the holes, and the cutout, have produced this Vectophone toolpath project. Now the final stage would be for us to write out the G code for these toolpaths. So I can close that form out now, and then simply come across and save those toolpaths out as G code. And also I would consider saving the part. So I'm going to come up to File, Save As, and save that as the Vectophone 2D toolpaths.crv file, and save that for later use.